Hey everybody, we're going to take a look at a mastering physics problem. So for all you physics folks out there, and it's problem 5.66, also in the textbook, problem number 66 in chapter 5. But the Unified Mastering Physics is open and ready for you all to dive into, and I just want to do one of the problems in here. So as you can see from the screen here, pardon my thing. It's an airplane. It's being pulled by a bunch of British police officers. They set the world record for pulling a Boeing 747. Our task is to figure out the force that each officer is pulling the Boeing 747 with. If you take a look here, I'm just going to scroll down. Estimate the force with which each officer pulled the plane, assuming constant pulling force and constant acceleration. Remember, Mastering Physics posts different numbers for every problem set. So my numbers, excuse me, are not going to be your numbers. So please don't go and try and do my problem with my numbers. Do your problem with your numbers, but this will walk you through it. The other thing, sorry for not being here, sorry. The other thing that this problem is a combination of kinematics and dynamics. The units 4 and 5 were our dynamics units. We're talking about the forces, the causal model of motion. Kinematics was the study and describing of motion. So we're going to combine those two in this problem and make use of all we know to figure out the force, the estimated force each officer is pulling with. So let me go ahead and bring up a blank screen here. So we have an airplane, and let me just switch off to a couple cool colors. Okay, here we go. So we have this airplane. And whenever I'm doing a force problem, I need to get a free body diagram. So the airplane is on Earth, on a surface. So, sorry. We have normal and weight, and we're not going up or down. We're not accelerating in the Y plane. We're only accelerating the X plane due to this pull from the 60 officers. So this could also be considered a tension, if you want to call it a tension force. And the problem does tell me that there's rolling friction. So we're going to go ahead and get ourselves some kinetic friction here. So F net is equal to ma. We are accelerating. I'm going to get my force equations in the X. So I've got that force applied, or that pull force. So sometimes we just call that an applied force. And we have friction opposing that motion. So ma is equal to F applied. And we know what we're going to be doing here with this friction equation, because in the Y direction, though we're not accelerating, we have normal up and weight down. We know then that normal is equal to mg. And we can go ahead and replace the friction equation with mu mg. We were given the value of the rolling friction. We know the mass of the plane. We know what planet we're on. We're looking for the applied force total to get the plane moving. And since we know that there are 60 police officers, we can divide that total force among the 60. We're assuming that it's a constant acceleration, there's a constant force, and that it's divided up equally. So approximately, the applied force divided by 60 will give me the number of the amount of force each officer is pulling with. So I know over here, I know the plane's mass, but I don't know the plane's acceleration. However, in the problem we were given, so let me just bring that back up. In the problem, we are given that we have a group of people pulling it. Where am I at here? Boeing 747. Yes, so there's the mass of it. The distance it's being pulled is 100 meters, and it's done in 53 seconds. Those are kinematic variable informations. If you are missing acceleration in one of your force problems and you were given kinematic information, that's your cue to do a kinematic problem to solve for the acceleration. Also, if you're looking for a displacement or how far something traveled and you're given force information, more than likely you're going to need to find the acceleration using forces and then use that acceleration in a kinematic problem. So in this case, we are going to use the kinematic information to find acceleration so that we can then solve our force problem. I'm coming back over to here. Okay. Here we go. So set up our kinematic variables. I'm going to slide over just in case my screen is short in the thing. So V final, V initial, X, A, and C. I'm going to go ahead and set it up. So the plane starts from rest. So it's not accelerating. It starts from rest, so it's not initially moving. The distance it traveled was 100 meters, and it did that in 53 seconds. I'm looking for acceleration so that I can then take that acceleration and pop it in here. I have no information about the final velocity of the plane, so that allows me to choose an equation that is missing V final to solve my problem. So that would be X final is equal to X initial plus VIT plus 1/2 AT squared. I'm going to go ahead and solve this for acceleration. So I'm going to get, I'm going to bring the, you can do your algebra on the side, but displacement, that's 1/2. So it'll be 2 delta X divided by T squared is equal to A. Remember, initial velocity is 0, so this whole term goes to 0. I want to get A by itself, so solve for A. Once I have A, I can go ahead and sub in my numbers. So I get 2 times 100 meters divided by T squared, so 53 squared. Excuse me. And 53 seconds squared. So if you got to do that in your calculator, I'm going to do that in mine real quick. Oh, sorry, calculator's on the other side of the room, of course. All right. So 200 divided by 53 squared gives me 0.71. So awesome. 0.07. And I'm just going to leave it at 0.07 meters per second. And that's to be expected. I mean, we're pulling a Boeing 747. I don't think it's going to accelerate very much. So we get the thing moving with that acceleration. So now I'm going to come up to my original force equation, and I'm going to solve for the force applied. So I'm just going to step over here. I'm going to rearrange this equation solved for the applied force. So I'm going to get mu mg plus ma is equal to F applied. I can factor out the mass. Yep, so let me do that. Mass times mu g plus a is equal to F applied. Now sub in 2,000 kilograms. And remember, these are my numbers, not your numbers. So you're probably going to have a different A, and you're going to have a different mass, and probably a different coefficient for rolling friction. So just, again, don't copy my numbers into your problem. Use your own numbers. So I think, hold on a second. I remember the, mass is 200,000 kilograms, 153. Mu of rolling is 0.02. Okay, 0.02. 0.02 times 9.8, and that quantity plus 0.07. Hopefully you guys can see this. I'm not too far off my screen. And that's going to be equal to F applied. So let's take and calculate that out. So 0.02 times 9.8 plus 0.07. I get 0.266 times 200,000. I get an applied force of 53,200 newtons. And I'm looking for the force estimate for each officer. So I'm going to divide that force by 60. Divide by 60, and I get, so let me come back over here. per officer, I'm going to get 886.66 repeating. So we're going to do 800 and 800 and you can just do 890 and just call it a day. 890 newtons. Physics doesn't always follow the sig fig rules, so no big deal. Or 886.67, whatever you want to do. But there we go. Awesome. So remember, we can do kinematic problems and dynamics problems together to get information. You just kind of have to remember the pieces for forces and remember the pieces for kinematics. Again, this was Mastering Physics, Chapter 5, Problem 66. In the Mastering Physics itself, it was 5.66. And if you have any questions, come see me or send me a message, subscribe, and I'll see you guys the next time. Thanks. This is my awkward ending.